We're going to look at the graphs for the sine and cosine functions. As we're looking at these graphs, we're also going to take a look at some of their properties, including even or odd, which are properties of symmetry, the period, the amplitude, and the midline. We're going to start with the sine function. So I've got the sine function here and angles in pi-fourths increments. Let's go ahead and just scroll down so we can see the unit circle there as well. And let me grab my pen. As I work around this unit circle, I am going to work, let's see, pen, and I'll just make that a little bit bigger. Okay, so I'm going to go ahead and work in pi-fourths increments. And I'm going to start at the positive x-axis with 0 radians. So at this point on the unit circle, I've got 1 for x and 0 for y. Sine refers to the y coordinate as we're moving around the unit circle. So the sine of 0 is equal to 0. Moving on to pi-fourths, that's going to be this angle right here. This is my 45, 45, 90 triangle. Both the vertical and the horizontal leg are radical 2 over 2, but I want the vertical, so that's going to be a radical 2 over 2. At pi halves, so straight up there, I've got the point 0 for x and 1 for y. Sine is y, so I want a 1 there. Moving over to 3 pi-fourths, so there's 3 pi-fourths. This is another 45, 45, 90 triangle. Y's are still positive in this quadrant, so that means that this y value is going to be another radical 2 over 2. So I get another positive radical 2 over 2. And then at pi, halfway around my unit circle, I've landed on the point -1 comma 0, and I get another 0. As I continue to work around the unit circle, I'm going to end up getting the same values, but I'm just changing my positive and negative signs. So over here in quadrant 3, my coordinates are negative for both the x and the y. So here at 5 pi-fourths, this is going to be a negative radical 2 over 2. So I have just some really nice symmetry here. A negative radical 2 over 2. Straight down there at 3 pi-halves, this is the 0 comma -1, so we get -1. 7 pi-fourths is right here. Y's are still negative, so I get a negative radical 2 over 2, and then back to 2 pi, which is where we started here, and I have a y value or a sine of 0. Now I want to go ahead and plot these onto the xy axis. So I'm taking just the y coordinates around the unit circle, and I'm creating those as points over here. So this is now y is equal to the sine of x. So these points have the angle measure, comma, the sine value. So this is my x coordinate and my y coordinate. So I'm going to go ahead and plot those now using this xy coordinate system. And I want to go ahead and just estimate radical 2 over 2 so we can put that a little more easily into our graph. So radical 2 over 2 is 0.7. Okay, so this is going to be a 0.7 here. So 0.7, 0.7, and then negative 0.7s for those. Okay, let's go ahead and plot these. So I'm going to go ahead and plot this guy in green. When my angle is 0, so these x's are the angle measures. When the angle is 0, the sine of 0 is 0. Next, we are doing pi-fourths, which is going to be right here, and that's going to be at 0.7. So let's do this at 1, which means this guy is going to be 0.5 here. This is going to be 0.75. So that's going to be about right here. And then at pi-halves, we've got 1. So pi-halves, we've got 1. And then right here at, this would be 3 pi-fourths, we have 0.7 again. And at pi, just working through here, we have 0. So that gets me through the upper half of my unit circle. Now I'm moving around the lower half of my unit circle. I'm going to go ahead and continue with these for my x and my y values. So next is 5 pi-fourths. So 5 pi-fourths lives right here. So 5 pi fourths. This is going to have a negative 0.7. So this right here is -1, negative 0.5. So negative 0.7 is going to be right here at 3 pi halves. So at 3 pi halves, we've got -1. At 7 pi fourths, which would live here, we've got negative 0.7 again, that nice symmetry. And then at 2 pi, we have 0. So if I were to connect these, I get one period of my sine wave. So you'll notice that each of the values around my unit circle refer to a point here. So this one is this point, this one is this point, this one is this point, and so on. That's how we get that sine curve. As I continue to look at some of the properties for my sine curve, this does continue on forever. Actually, let me go back to my green. So this does continue on forever. I just did one period because as I work around my unit circle again from 2 pi to 4 pi or 4 pi to 6 pi, I'm going to end up landing on those same values. So if I were to extend this out, I'm just going to continue with the same shape in both directions. So really, I can put in anything here for my domain. I can take any angle measure, no matter how small or how big, negative or positive. So my domain is all real numbers. All real numbers, or you can write that as negative infinity to infinity. My range, though, this does live on the unit circle, which means that the biggest these y values can be is 1. The smallest they can be is -1. So these are bound in terms of their range by 1 and -1. So the range is going to be square brackets because I'm including those, -1 to 1. Amplitude. Amplitude takes the middle, or what we would consider the midline. Let me do this in green or red. So the midline is going to be just splitting that right there in half. And it measures from the midline to the maximum or from the midline to a minimum. Well, we can see that this distance right here is a distance of 1. And even if we're negative here, we still consider that a positive value. So amplitude is midline to maximum or midline to minimum. And that's going to give me an amplitude of 1. And then my period, that's how long it takes to do a repeat. So as I switch over to yellow here, I'm going to trace out a unique shape until I hit 2 pi. And then I'm going to trace out that unique shape again. So I've got a unique shape just within the x values, or the angle values, between 0 and 2 pi. So we say that this is 2 pi periodic, or we have a period of 2 pi. So we say this is 2 pi periodic. If we happen to have a b that was multiplying by the x, that would be a horizontal stretch or compression. We would adjust that period by dividing by whatever that multiplier was. So the period for a transformed sine function, you're just going to take 2 pi, which is the original period, and divide by whatever that multiplier b is. Okay, number 2. Sine is, this would be either an even or an odd function. Let me go ahead and draw sine out in both directions. So here's one period, so that would be between 0 and 2 pi, 2 pi to 4 pi, and so on. And if I were to go negative with this, it would look exactly the same. So what we have here is an odd symmetry. So this is odd because it's symmetric with respect to the origin. That means that wherever I find a positive value, I'm going to find its negative value, kind of reminiscent of a cubic. So sine is an odd function. Odd here has nothing to do with 1s, 3s, and 5s, but it has everything to do instead with symmetry. So odd means that sine of negative x is equal to, the negative sign is going to pop out, negative sine x. For example, if I take a look at the point here at the maximum, this point right here is at pi halves. And we get a point there at 1. So my point right here tells me that the sine of pi halves is equal to positive 1. Well, I want to look at the sine of the negative of that. So the sine of negative pi halves, according to my rule here, the negative should pop out. So if I take a look over here at negative pi halves, I end up at a value of negative 1. So this point right here tells me that the sine of negative pi halves, look at that negative sign sort of pop out in front, right, is negative 1. So we end up with this odd property. The negative sign comes out in front. Okay, now let's do the same thing for cosine. As we're analyzing our cosine graphs, we're going to be looking at the x value as we work around the unit circle. So we're taking these x's to mean different things now as we're going from the unit circle over to the xy grid. X is going to represent our theta, and y is our output, which is the cosine of x. But let's go ahead and first start by computing each of our cosine values. So we're going to go ahead and start at 0, which is here. So that's 0 radians on my unit circle. This point is 1 for x, 0 for y. So the cosine of 0 is equal to 1. Moving over to pi fourths. Now I want those x values, still a radical 2 over 2. So radical 2 over 2, or we're going to estimate that as 0.7. Pi halves, so that's going to be straight up here. At pi halves, we've got the point 0, comma 1. So the cosine is the x value on the unit circle, which is 0. Now for 3 pi fourths, I'm looking for not the y value, but the x value. This guy is going to be negative radical 2 over 2. So negative radical 2 over 2, or negative 0.7. And then all the way over here at pi, I've got the point negative 1 comma 0. So we get negative 1. As I continue to work around, I get another negative radical 2 over 2 for 5 pi fourths, which is negative 0.7. 3 pi halves straight down. This is the point 0 comma negative 1. So I get a 0. 7 pi fourths. Now my x's become positive, so I get a radical 2 over 2, positive 0.7. And then back here at 2 pi, so all the way around, I'm back to this point where the cosine is equal to 1. As I graph these, I'm also going to get a periodic or a repeating shape, but it's going to look a little bit different. So as I put this into my graph below, we're going to treat this first row as my x's. These are my angle measures. And then my second row as my y values, my outputs, which is the cosine of those angles. Okay, so let's go ahead and plot these. The first point is going to be 0, comma 1. So 0, we're letting that be 1. So 0, comma 1, it starts here. The next point is pi fourths. So there's pi fourths. So it's pi fourths, positive 0.7. So let's see, we said that was 0.5. So positive 0.7 is about here. The next point is pi halves, comma 0. 3 pi fourths, so that's going to be this guy. 3 pi fourths, this is negative 0.5, negative 1. Negative 0.7 is going to live here. Pi negative 1 is here. 5 pi fourths, which is going to be halfway in between there. So 5 pi fourths, negative 0.7 again, which is here. 3 pi halves, 0. 7 pi fourths, so halfway between those next 2 points, is back to positive 0.7. And then 2 pi is back to 1. So I can see that I'm repeating that pattern. So as I draw that in, let me draw it in green. We end up with a similar shape, but I'm starting instead with a value of 1 on the y-axis. This does continue. I'm just running out of real estate to continue, right? So it does continue. Let's go ahead and work through the properties of cosine. They're really similar. I can put in any angle measure, right? Small, big, negative, positive. So my domain is all real numbers, or you can say negative infinity to infinity. My range, though, is again bounded by 1 and negative 1. Remember, these are fractions or ratios of the sides of your right triangle. So these can only be as big as 1 or as small as negative 1. So my range is negative 1 to 1, inclusive. So I'm going to use square brackets. So negative 1 to 1. Amplitude. So we measure the amplitude from the midline. So the midline splits this in half. And if I measure up to a maximum or down to a minimum, we see that that distance is equal to 1. So the amplitude, midline to the max or midline to the min, is going to be an amplitude of 1. The period, this one does again repeat between 0 and 2 pi. So the period is 2 pi. We call that 2 pi periodic. If I happen to have some kind of a vertical stretch, a horizontal stretch or compression, which is this multiplier b, we can adjust the period by doing 2 pi, the original period, and dividing it by b. Let's take a look at cosine in terms of an even or an odd function. I'm going to draw it out. So here is the basic shape, sort of a horseshoe-ish shape. This is from 0 to 2 pi, but it continues 0 to 4 pi and so on. And then I can also go backwards. As I'm looking at symmetry, I notice that this one has really nice symmetry about the x-axis. Notice how both sides here are exactly the same on the left and on the right. So this y-axis symmetry means that my function is even. So we say that this is symmetric with respect to w, r, t, the y-axis. That y-axis symmetry, the even property, means that the cosine of negative x, the negative sign goes away, is equal to cosine of x. So we go ahead and just test one of these. We can do, let me do it here. We can go ahead and test the cosine of, let's do the cosine of, let's do it at 2 pi, actually. That'd be a great one. So let's do the cosine of 2 pi. The cosine of 2 pi, that's equal to 1. If I were to look at the cosine of negative 2 pi, it's going to live over here, or if I'm on the unit circle, negative 2 pi lands me in the same exact spot, right? So I'm still either way at pi or 2 pi at a cosine value of 1. So I'm here, and the cosine of negative 2 pi is also equal to 1. So that even property means that the negative inside goes away. As I look at these two side by side, I can actually see that they're the same shape. They just start in a different place. A nice way to think about where these start is with the y-axis and the origin. So I'm looking at this first one, which is my sine wave. We think of one period, which is from 0 to 2 pi. Having this shape, so this is the sine of x, y equals. And over here on the cosine graph, if I look at the interval 0 to 2 pi, I have what I think of as kind of this horseshoe shape. So this is one period, 0 to 2 pi. They are the same shape though. I can trace out the same exact shape. They're just shifts from one another. So y is equal to the cosine of x. Let's do some examples. So we want to go ahead and identify these properties for some of these sine and cosine graphs with some small transformations in them. In this first one, I've got that y is equal to 3 sine x. So this 3 on the outside is multiplying my original sine values by 3. So this is a vertical stretch. by 3. So I end up multiplying all of those sine values by 3. So if I have y here, and I have the sine of x here, and then the one that I'm looking for, oh, sorry, I want x here. So x here, the sine of x here, and then what I'm looking for is y is equal to 3 sine x. That's better. I can go ahead and start to compute these. Okay, 0. Well, the sine of 0 is 0. So the one I'm looking for, I'll put a box around this, is also equal to 0, so I'm here. Let's go ahead and skip over to pi halves. So at pi halves, the sine of pi halves is equal to 1. So 3 times the sine of pi halves is equal to 3. So let's do 1, 2, 3. So I'm going to call that 3. If I skip over to pi, the sine of pi is equal to 0. Multiply that by 3, I get 0 again. If I continue here, I can do 3 pi halves next. On my unit circle, that is straight down. So that's going to be 0, negative 1. So I get negative 1, which gives me a value of negative 3. Negative 1, 2, 3. Negative 3, and then back to 2 pi. So if I draw this in, what I've done is I've stretched the sine of x. I can also go ahead and graph the sine of x just so you can compare. So if I were to graph these values, you can see that it is going to be much flatter than the other ones. And I'm using this guy as 1. Okay, so there's the difference. So you can see that vertical stretch. Okay, so let's go ahead and identify each of the properties. So the domain of the function that we're looking for, that's the function in blue. So the domain of 3 sine x, still all real numbers. I can still put any angle measure in there that I want, but my range now, I've stretched this. So now it goes as high as 3, as low as negative 3. So my range is negative 3 to 3. Amplitude, we measure the amplitude from the mid-range. This is related to the range. So now those peaks and valleys have a height of 3. So my amplitude is equal to 3. The period, I'm still finishing that shape within 2 pi. So my period is still 2 pi. And the midline, we haven't moved that. The midline is right there on the x-axis. Okay, so for this next one, let's do 4 cosine x. I'm going to do another t-table. That's a nice way to go. So we're going to do cosine x, but the one we're really looking for is 4 cosine x. So similar to what we just did, I'm going to take the original cosine values and I'm multiplying each of those by 4. So when I put 0 into cosine, I get 1 back. But I'm going to multiply that and I'm going to get 4 instead. So let's call this 1, 2, 3, 4. So I'm going to go ahead and start with 0, 4. Let's go ahead and also skip just right over to pi halves. The cosine of pi halves is equal to 0. Multiply that by 4. It doesn't do much, negative 0. Let's do pi next. This is a negative 1. Multiply it by 4 and I get negative 4. So pi negative 4. And 3 pi halves. That's straight down on the unit circle, so it's going to be at a 0 for x, so another 0. And then last but not least, 2 pi, that's going to be 1. Multiply that and I get 4. So I get that same horseshoe shape that I'm finishing within 0 to 2 pi, but I've got some changes to the range and amplitude. So my domain is still all real numbers. My range is changed. Now it's going to go as low as negative 4, but it's bound up above by 4. So my range is negative 4 to 4. Amplitude, remember this is related to the range. So my midline still is at the x-axis. And as I'm measuring the height of those peaks or valleys, this guy has an amplitude of 4. And the period, I haven't changed that at all, so it's still 2 pi. One way to see that the period hasn't changed is because there's nothing multiplying by that x. However, in C, we are multiplying the x by something, and we are multiplying the x this time by 2. So I'm going to go ahead and start out with the period of this one. So this one has a period of, I start with the original period of 2 pi, and I divide that multiplier. So I end up with a period of pi. So I know that I'm going to be completing one cycle of my cosine, this is cosine, right? Of my cosine graph between 0 and pi. I also have this negative out in front, and the negative out in front is going to do a vertical reflection. So this did look like that. If I do a vertical reflection, it's instead going to look like this. So I can go ahead and graph this using my transformations. I know that I'm looking at, let's see, I have no change in amplitude. So my amplitude is still going to be 1 because I only have that negative out in front. So as I'm defining this, this was at 1, but as I flip that, it's going to be at -1 instead. So I'm going to call this guy -1 here. So I'm going to have -1 here, and we'll call this +1. So I'm starting at -1. Whoops, I don't want Google Assistant, but thank you. Okay, so I want -1 there. At pi halves, it's still going to be at 0. Oh, actually, no. At pi, I'm going to be at -1. So now I'm squishing that. So this is going to be from 0 to pi, which means that the horseshoe middle is going to be at pi halves. So the horseshoe middle is going to be at pi halves. And I can go ahead and just kind of sketch through the rest of this. I could also do this with a t-table. So I can go ahead and take my x values, and then I can do negative cosine 2x, and I can compute each of those values. You can also do this, of course, with Desmos. You can do this with your calculator, but transformations are the quickest way to get to these. So notice how I took that. So step number 1, right? I just took my original cosine graph. I reflected it, so I knew that it was going to look like this instead. And then I made sure to bound it between 0 and pi, which put my peak at pi halves, and then I was able to draw the rest in. So you'll get good at these, but the nice thing about these periodic graphs is that you know that you're always working with the same shape. Now, I could, of course, continue to draw that out, but I'm going to go ahead and leave it and work on the next one. Okay, so this next one. So now I've got -1/2 sine x divided by 2. Oh, actually, I didn't finish the domain and the range. I talked about it, but let's go ahead and put them in. For the last one, domain is still real numbers, always. The range, it's still bound by -1 to 1 vertically. My amplitude, I still have a height of 1, and the period has been shrunk, and that period is pi. So remember, that's 2 pi divided by b. In this case, that multiplier b was 2, and we end up with our pi. This one also has a change of period, part D. So for this one, my period is going to be the original sine period of 2 pi divided by, this is actually a 1/2. So I can think of this as 1/2 x. So divided by 1/2. 2 pi, I'm going to reciprocate that guy. So I get 2 pi times 2/1, and I end up with a period of 4 pi. So now when I'm thinking about what is my sine wave, I know that I'm going to complete that sine wave, not in the traditional 0 to 2 pi, but now I'm going to complete that between 0 and 4 pi. And then I'll put that halfway mark right there at 2 pi. I can even put the peaks there at the halfway in between points there, pi, and this would be 3 pi. Had to think about that one. 3 pi. These are the 5 key points, and we're going to talk about this a lot in the next video, but I just want to highlight these 5 key points. They're really nice to work with. I know the basic shape. I know what the period is, so I can start just to sketch this out. I also have a negative out in front, and I have a 1/2 out in front. So I have a little more work to do. If I were to go ahead and do the 1/2, that means instead of having a height or an amplitude of 1, I'm instead going to have an amplitude of 1/2. So that's going to make these compress. So it's going to look like that. The last thing I've got to do is this negative out in front, which is a vertical reflection. So I want to turn this guy upside down. And as I turn this upside down, let me draw this in green, and I'm going to redraw it because it's messy. Instead of going up when I start, I'm going to go down when I start. So it's going to look like this, and then like this, finishing at 4 pi. This is going to be 2 pi. Minimum is at pi, maximum is at 3 pi, and now I'm bound by 1/2 and negative 1/2. Okay, so we can go ahead and draw this in here. Let's see, this means this is going to be 1/2, and that point there is going to be negative 1/2. I want to finish this at 4 pi. So I'm going to have a point at 0 at 4 pi, a point at 0 there. I'm also going to have a point at 0 halfway in between. And now I do my halfway in between marks here, but since I reflected it, it's a minimum. Halfway in between at 3 pi, I reflected it, so that's a maximum, and I can go ahead and draw it in. And it would continue, of course. Okay, so domain, still all real numbers every single time. I don't even really need to include that, but I do. My range now, this one has been squished, compressed in the vertical direction, so that means my range instead is negative 1/2 to 1/2. This also changes my amplitude. So the height is just 1/2 midline to peak. And the period, this time we stretched this guy. So the period is 4 pi. Okay, so for the last couple, we're starting with a graph. And we want to go ahead and define, I'm not doing the domain because those are all real numbers, but let's go ahead and define some of these properties with some additional shifts. It's easier to look at the shifts, at least to start off with here, using a graph that we're starting with. So first of all, the range. This is going to be the boundary in the y direction. So it looks like I can go as low as -4, but I'm bound up above by 2. So that gives me my range of -4, 2. My period. So this is when I repeat. So I can start my curve and finish my curve. It's got that horseshoe shape, so it's looking like a cosine, which is this one right here. And I'm doing that within 0 to pi. So this guy is pi periodic. So my period is pi. Amplitude. So the amplitude, a good way to do the amplitude, since I have one that's been shifted down, is to go ahead and take this entire height here. So I've got -4 to 2, my entire height is 6, and divide that by 2. So my amplitude is going to be 3. It's half the entire height. Okay, so the midline, let's go ahead and draw that midline in. So I want 3 from the midline up and 3 from the midline down. So that goes right through -1 on y. So y is equal to -1. And since this had the horseshoe shape for that first period, we say that this guy is cosine. Okay, so here is another one. So let's go ahead and start with the range. So the range is going to be the boundaries in the y direction. So this is bound by -5 and -1. So range is -5 to -1. Period. So I am going to start this shape here, and I can draw out the entire shape, and I end it right here. So that tells me that my period goes to 4. So my period is 4. It doesn't have to have a pi in it, but I do repeat that in an interval of 4. Okay, so amplitude. So for the amplitude, I'm going to take the entire height, which is right here, -1 to -5. My entire height is 4, and divide that by 2. So my amplitude is equal to 2. Midline is going to go smack halfway in between. So there's my midline. I'll draw it as a solid line. So my midline goes through -3. So y is equal to -3. That curve that I drew out looks like this. You can also think of this guy kind of as an S shape, and that's a great way to remember that this is my sine graph. So you will get more comfortable with these. I didn't use my calculator or Desmos much because I really wanted to get some big picture ideas out there, but do feel free to use your tools as you're learning about the sine and cosine graphs.